continue with the examples for section 2.1. So in exercise 9, we're going to use the Morgan's law to write the negation of each statement. So here we have the statement, the car is red and the truck is blue. So this is a P and Q kind of statement. So if we're going to negate, we're going to do negation of P and Q, we get negation of P or negation of Q. So the negation of this will be the car is not red or the truck is not blue. The truck is not blue. I will study or I will fail. This is a statement of the form P or Q, and so the negation of P or Q is going to be negation of P and negation of Q. So this will be I will not study, negation of P, and I will not fail. C has x bigger than 5 and x less than 10. These are P and Q. So once again, the negation of P and Q is negation of P or negation of Q. And then the negation of x bigger than 5 will be x is less or equal than 5, or x is bigger or equal than 10. That'll be the negation here, which comes with this rule once again. Now, D will be the number is even or the number is divisible by 3. So we have here the number is even is P. The number is divisible by 3 is Q. And so we have here, once again, a P or Q situation. And if we're trying to deny it, we're going to get a situation negation of P and negation of Q. So it will be the number is not even, which is to say the number is odd, and the number is not divisible by 3. Question 10 says, use the Morgan's law to write the negation of minus 5, x is between minus 5 and 7. Notice that we can write this as x is bigger than 5, than minus 5, and x is less or equal than 7. Since this is an intersection here. So if we're going to write the negation of this, we're negating an n. So we'll say x is actually less or equal than minus 5, or, and then we negate this one, which is the opposite. X is bigger than 7. Okay? Now let's move to question 11. So here we want to determine if each of the statement is a tautology, a contradiction, or neither. So for doing this, we need to do truth tables. So once again, we do P, true or false. Negation of P will be false or true. And if we have P or negation of P, then we're doing this too. We're operating these two columns, and we get to use the or. True or false is true. False or true is true. Notice that P or negation of P has all of the values of true being true. So this will be a tautology. Now, P and negation of P will be the opposite. Once again, we have P, true or false. Negation of P will be false and true. And then P and negation of P works with the rules of the AND. The rules of the AND tells me that it's going to be true only if both of them are true. But in this case, we have true or false and true, which is false and false. So this is a contradiction. Now we do P and Q or not P. So let's go P, and we have Q, so we have true, true, false, false. In Q, we have true, false, true, false. P and Q, we have true, true, and then false, false, and false. And we need negation of P, which will be false, false, true, true. And then finally, we need P and Q and negation of P. So we're comparing this two. We're comparing it with the AND. So true and false is false. False and false is false. False and true is false. False and true is false. So this is a contradiction. Finally, we have negation of P or negation of P. So this is only a single proposition. So I can do P, true or false. Negation of P, false and true. And then we got to do P or not P, which we actually kind of did before. But if we're using an or, then this is going to be true and true. And then, of course, the negation of this is going to be false and false. So this value is a contradiction as well. Remember that here I'm going along the video to showcase how everything is done. But I know that this is not the ideal handwriting, so make sure to check on the solutions that are going to be posted later, because I will have these solutions in detail and much better written than what you see in this video. Now let's go to exercise 12. Let's use a truth table to determine whether the following statements are logically equivalent. So we want to do P and Q or P and not Q and P. So this is a complex one, but it only has 2 entries, fortunately. So we're going to do P, and so we have true, true, false, false. We have Q, which is true, false, true, false. We can do here P and Q, which is true, false, false, false. And then now we can do negation of Q, which will be false, true, false, true. And now I'm going to do P and negation of Q. Notice that I'm going to be using this 2 for this one. So true and false is false. True and true is true. False and false is false. And false and true is false. So we have that one there. Now we're finally going to be doing P and Q and or P and not Q. So we're going to do the comparison here. And so because we're doing that comparison, then we're checking with these values. Okay? And so the values of true are with an or. So true or false is going to be true. False or true is going to be true. False or false is going to be false. And false or false is going to be false. Notice that indeed they have the same truth values. P and Q or P and not Q, they have the same truth values. So these are logically equivalent. So we can say that P and Q or P and not Q are equivalent to just P. Logically equivalent. Okay? All right. So let's move on to the next one. So let's use logical equivalences, not truth tables, to simplify this. Okay, so first we're going to start by doing De Morgan's law over this negation. So we're going to go, this is equivalent to negation of P, and then this or is going to change to N, and then negation of Q, and then or P and Q. And this is by De Morgan's law. This is equivalent to P and not Q, and we can look at this like this, or P and Q. And this is double negation. Negation of the negation is the original. Now, we can use distribution here. We're going to distribute P over this. So we're going to have P or P and Q. This is going to be the first thing. And we're going to have this in negation of Q or P and Q. Notice that we can just simply use absorption laws because we're doing or. And so here for P or P and Q, then we can just simply call this as P. This is P. And just call it by absorption law. Absorption law. And now with this, we can kind of distribute this once again. So this is going to be P in, and then we're going to have negation of Q or P, right, over this first one. And then in negation of Q and Q, negation of Q or Q. And so because this is negation of Q or Q, this is true or false. So we get to pick. So this becomes true. So this is called a negation law. Remember, not Q or Q. This becomes true by negation law. And so now we can transition to this only being equivalent to B and negation of Q or P. Okay. And simply here we can once again check and distribute. And this will be P and not Q. Or P and P, which is just going to give me P, right? So we have P and not Q, or just P. And so because we get to pick, we can just simplify, and this is just going to be equivalent to P. So that's the identity law in here. So identity law, and this is distribution. Once again, and so this is very long to do everything with the laws, but we can take a minute to just get there. Now, question 14 and 15, we have that P, it is raining, Q, the ground is wet, and R, the grass is green. So we want to write this in symbolic form. It is raining, and the ground is wet, or the grass is green. So this will be P and Q or R. It is not true that it's raining, or than the ground is wet. So it is raining is P, not P, or the ground is wet, so not P or Q. The grass is green, which is R, but it is not raining. But is an N, remember? Not raining, R and not P. Now, for 15, we want to use a truth table for proving this. P and Q or R is equivalent to P and Q or P and R. So this is going to take us a bit because then three propositions is going to be a big table. We're going to have 4 entries for true and false. And so that's going to transform into this big table. Okay, and so the R, true, false, true, false, true, false, true, false. Then I'm going to need every single one of these elements. So I'm going to need P and Q. I'm going to need P and R. And those are here. And I'm going to need Q or R. So P and Q. So let's go with this one. So this is true, true, and then false, 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 false. P and R is true and true. Then it's true. True and false will be false. True and true will be true. True and false will be false. False and true, false and false, false and true, false and false. So everything else here will be false. Now for the Q or R, then we're contrasting between the columns Q and R. And so we have true and true. The OR is true. Remember that for OR, always going to be true as long as we don't have a false, which is like the case here in the 4th row. So here we have false, then true, 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 and then we have a last false down here. Okay. We have this, and this. So now we need the unions or the interaction. So let's do P and Q or R. And that one, once again, is checking this column with this column. And so we have an N. So as long as they're both true, we're fine. So true and true. We have another true here. We have a true and false, so false. And then we have a bunch of false, which no matter what, then it's going to produce falses with this. Since if we have one false, then that's going to pretty much change everything. So now let's do the last one to see if they have equivalent values. Let me move this around a bit. And then we're going to check P and Q or P and R. And so this is checking these two values, and we're checking with OR. So true or true, true, true or false, false, false or true, false, false or false, false, and everything else is false here. So notice we don't seem to have an equivalence here, unless I made a mistake. Yeah, it seems like I made a mistake here. Let me check P and Q and P and R. True or false? Yeah. So this too. Notice true or false, we get to pick the true. So this is really true and true. So now notice that indeed this has the same values and they're logically equivalent since they have the same true values on the column. Okay, well, this is the end of the section 2.1 exercises.